let's begin. So here, these are the topic that I'm going to discuss. I'm audible clearly before starting. At least we should know. Yes. Okay, fine. And if you have any Q&A, you can put in the chat. After the session, I will give you the answer. Okay. So these are the topic I'm going to cover. So what is protocol? So first thing is that it's come to the question, what is protocol? So we know that protocol is basically a kind of a rule that we have to follow. Like in our daily life also, we have some protocol that we follow for any task. Here in telecommunication, if you see, we have a OSI model that we follow. This is OSI model. So in this OSI model, we have some layers. So the physical layers that you have seen here, that is the lowest layer of the OSI. This physical layer mainly we do the responsible for transmission and reception of unstructured raw data between the device and the physical transmission medium. So that we are using. So in telecommunication, we can say that when we deploy here your radio frequency, wireless transmission, modulation, demodulation kind of terminology will come. So these are the terms that we are using in this segment. Now, second thing is that here we have a data link layer. Data link layer means what? This layer basically provide node to node data transfer. It means here what we can provide, it's like a two entity you are connecting directly. So that's why here we need to handle error correction from the physical layer what we are getting. So that's why here we have the MAC layer. So here we mainly involve the establishment and the maintaining the reliable link between the different nodes or cell tower who is managing. So this is managing by MAC sublayer that you can see here, so that we can handle the error detection and the correction. In this one, the data link layer, you have two layers. One is called LLC, logical link control. That also we can say that RLC, you know. So this logical link control sublayer is responsible for identify the network layer protocol and encapsulated them. So they can manage the communication between the network layer and the data link layer. Second one, we have MAC sublayer. So we know that it's a medium access control sublayer, which controls the hardware that is responsible for interaction between different medium. So that we call here. Then we have here network layer. This network layer means what? It's a packet forwarding which include routing through intermediate router. So this is the part we are using here. Then we have here transport layer. So transport layer means what? Basically, this layer provide transparent transfer of data between end system or the host. It means it is responsible for here end-to-end error recovery and the flow control. So which we can say that it's like a radio link control layer, because here we make sure the data that are delivered, that data must be error free, that data is in sequence format, and there is no loss or any duplication. Then you have the session layer that you are managing here. It means the layer control connection between the two different entity. So that one. And the last one, you have the presentation and the application layer. So application, you know very well, like your internet, voice call, these things. So these are the things that we are providing here in this scenario. Now, second category we have, as when I'm talking about the 5G, so we have two layers. One is called layer 3. Layer 3, we can also say that RRC, and layer 2. We can also say that SDAP, PDCP, RLC, and the MAC layer. So signaling protocol, what they are. So basically signaling protocol rule the governance how device in the network communicate with each other. That it means how you are sending and how you are receiving. So when I'm talking about signaling protocol, so what kind of protocol it will come here? So it will come here like your X2 AP protocol, and you come here XN AP protocol, NG AP protocol, and S1 AP protocol for the non-standalone. So this kind of protocol it's come. So when you are using the X2 AP and the S1 AP, mainly this protocol we use for the EPC purpose actually, or E node B to E node B or G node B to G node B. And when we are using XNAP, so this one we use for the 5G, mainly for the 5G. Second, we have the transport layer. So what is the meaning of transport layer? So transport layer basically a kind of protocol where we want to deliver the data across the network interface. It means this protocol makes sure that the data which we are sent from one place arrive correctly to the other place. So this is the main important function actually. So how this transport package is working. So in simple term, when you are talking about the transport protocol, imagine this transport protocol act as a postal service of the network. It means they are responsible for packaging the data, like your letter and the package that you have, and address is correctly, so that it can ensure that we can transport that packet across the network correctly. And once you receive, it means it confirm also, like when you are sending one letter from one place to another place, the postman is collecting the letter and he is sending. So this is all transportation. And when you receive the OTP, your packet received successfully. So like this. So what are the function we have? So here we have the function like header and compression decompression. It means reducing the size of the data header so that we can make sure the data is transfer more efficient. Second one is that ciphering. Mainly, we can say encrypting data for the security purpose. Third one, we have the segmentation and concatenation. So segmentation is like this. We break down the large message into the smaller message and then reassemble this message to the destination side. Sometimes your packet is big, so what you do? You break the packet in a small packet, then you clear that packet. Same thing network is also doing. You break the packet and then you combine the packet and then you transmit this packet. So this is the function for this packet. Okay. Then we have in sequence delivery. It means make sure data packet received in order they were sent, and we have the automatic retransmission request. So automatic resending data if it is not received correctly. It means manually we don't need to send again. So here we can see an example like here we can see RLC protocol. So RLC protocol basically it's a kind of protocol and ensure that the data is delivered from the network to the mobile device and vice versa effectively. So without any error, we have to transmit. So RLC will handle the ARC protocol and maintaining the sequence of the data so that the end user can get the data correctly. So guys, here you can see these are the protocol specification for the 5G. So if you want to learn about yourself, you can follow this specification. These all are 3GPP specification. So here you can see that this is the source 3gpp.org. From that source, you can go and you can learn. So we have 38.321 mainly for the MAC layer. We have 38.322 mainly for the RLC layer, 38.323 PDCP layer, 38.331 RRC protocol, 38.324, not 38, it's 37.324. That is for the SDAP. So whenever the things is coming for the LT and NR together, they always come to the 3GPP release 37 series. Here in the right side, mostly the protocol you are getting from the G node B to G node B and G node B to AMF. So or EPM. So that's why you have to go each specification separately actually. If you want to learn about XN protocol, so you have to start from 420 to up to 424. And if you want to learn about NG protocol, you have to start. So XN protocol means what? G node B to G node B, if they are communicating, they are using XN protocol. And there is it's a similar to like X2 protocol that we had in LT. And G node B, if they want to communicate to the AMF, they are using XN protocol. So this is similar to like S1 when E node B want to communicate to MME. So these are the terminology that we are using here in the same way. So now we will see about 5G NR protocol architecture and the structure, how it's look like. So this diagram, I think very familiar, everyone know. Okay, so this is the 5G system architecture. 1 minute. Hello, hello. I'm audible? Yeah. So here you can see this is the simple architecture that we are using. So between device to the RAN. So here we have the user equipment. Okay, this is mainly either your smartphone or your IoT devices or your V2X devices, or you can say that CP, customer premises equipment. Here we have the radio access network. So device to radio access network, we are saying air interface actually mainly. So this radio access network could be either NG RAN, next generation RAN, or it could be either E node B, it means next generation E node B, or it's a G node B. Anything, it could be here. Now, then we have here EPF. So if you see here, we have point. So G node B wanted to connect to EPF or they want to communicate. So they have to use NT interface or they can use NG interface to communicating. So EPF is the part of the 5G core network. Mainly it's handle user data plane for the transmitting the data. It's like a data plane so that you can access your internet. Then here you have the data network. In LT, if you remember, it was DNN. Here we have data network. So this data network mainly we use for accessing the internet or the private network so that user can access everything. Now here we have AMF, Access Mobility Management Function. So this manage all the aspect of the mobility in the network, including the registration and the connection part. So RAN is connected to the AMF via N2 interface, or maybe it will connect via NGC interface. Device is connected to AMF via N1 interface, or we can say that this is the NAS interface. Anything you can say, there is no problem. Now, if you see, this is the new terminology we have that is called SMF. SMF mainly manage the session management for data transfer. So we will see in detail actually. Then we have the PCF that is called policy control function. So this policy control function manages the policy for the network behavior. Then we have the UDM. So UDM manage the user data and the authentication. So UDM we can say that unified data management. It's a similar to like HSS in LT where we store our subscriber data. Then we have the USF authentication server function, authentication user where they can attempt to connect with the network. So guys, these are the function. Now in the 5G, when you are using service-based architecture, we are we are using this protocol to communicate between each and every network function, and this term we call SGTP2. Okay. HTTP2, why they introduce actually? The reason is that HTTP2 provide better performance. It means HTTP2 protocol we include here like multiplexing, allow multiple requests and response so that they can intermingle on the same connection actually. So this is the reason this can reduce the latency which involve in setting up multiple TCP connection during the load time. Okay. Also, HTTP2 will provide you some benefit like stream prioritization. Because HTTP2 will allow you client to prioritize the request and letting the server know which resources are more important. And this is very crucial in any 5G service-based architecture because in the 5G we have different kind of services available in the network so that we can provide here these services. Then HTTP also provides server push. It means this is a kind of feature that enables server to send the resources to the client before the client requests them. It means in the service-based architecture, this can improve performance of preemptively loading necessary data for the different services. So, and also HTTP2 protocol is better secure. So that's why they have better transport layer security. So that's why in the 5G we need it enhanced security. So that's why they choose this concept actually. Now here you can see this is the access mobility management function. So what is access mobility management function? So when I'm talking about access mobility management function, so we can say that this mobility function understand like this. Imagine you, you you are going to one big shopping mall. Okay, so when you enter to the shopping mall, you go to the information desk. Always in the shopping mall, they have the information desk where they provide you some kind of a map, and they will in that map you have the direction to your favorite store wherever you want to go. So this information desk keep track of you where you are so that they can guide you quickly if you need any help getting from somewhere else. Okay, so that's why this is the things in the 5G. AMF is act like CM. AMF is like the information desk which provide your phone to get registered on the network. It is like checking into the mall. It means the entrance point. Okay, and this AMF manage your connection, make sure you send and receive data like somebody you want to call or IoT services or internet services. It help the network keep track your phone location wherever you move. It makes sure your phone is allowed to use the network during entire scenario. So that's the plus point. So when I'm talking about the AMF, you remember the most important function of AMF is that registration management. Okay, it means AMF handle the registration process when device connect to the network and maintain a profile and the session state. This is one thing. Second thing is that connection management. So imagine signaling between you and the network. Ensure that you can establish and maintain the connection for the communication. Third one, we have the reachability management. AMF keep track the 5G device state, whether device is in active state or whether device is in the ideal state, so that they can optimize the resources depend upon the utilization. And the most important, we can say that mobility management. So when the device move from one place to another place, AMF manage handover between the different network cell to maintain the seamless connection. Also, AMF managed to transmit the session management message between device and SMF. So here it transmits the message that is related to the session management, coordinate with the session management function to maintain the data session for the device. So these are the functions that they are managing here. And AMF also manage similar to like MME, that is called authentication and authorization. Authentication and authorization. So AMF work with where? If you see here, AMF work with AUSF. This is your AUSF. And this AUSF basically authenticate the device and ensure that this device can access this network so that it verify the services of each user that allow to access through either normal scenario or through the network slicing. So when they are using network slicing, so they have to check with the network slice selection function too, because they will interact with the network slice selection function also. So this is the function that we have for the AMF. Second, we have the SMF, that is called session management function. So in simple term, if you see that this is your SMF, they are connected to the UPF via N4 interface. So it's like we can say that it's like a concept. You are in some music concert, okay, where your ticket not only give you the entry, but also it will tell you where you can sit and where you can go to the different area of the venue. So that will tell you. So once you are uh, so there is some staff member that is helping them to provide them where you have to sit. They will guide you how you can interact with the session. Okay, in the 5G, we have the same. SMF is like a staff member when your phone want to start using the network. Okay, it means like when you want to browse any internet service or you want to watch any video services. So SMF set up your ticket a session that allow you to send the received data, and it decide which network path you have to use and where which IP address we need to assign. So that's why SMF will handle this path also. So SMF main function is that session management. It means SMF basically allocate you IP address. Okay. SMF will handle this UPF selection and the control. So SMF will select the UPF selection and the control. It means it select to manage the UPF which is responsible for handling and routing the user data. Also, SMF manage the UPF tracking traffic direction control also. So SMF control the flow of data through the UPF and ensure that the traffic is directed appropriate to maintain the quality of service. So this is the mainly function for the SMF. Now we will see the UPF. So here UPF also I want to explain in simple word. UPF is very important. Here is the location for the UPF. So you can see that UPF is directly connected to G node P via N3. UPF is connected to the SM via N4. UPF and DN, data network, via connected to the N6. So in the 5G network, UPF you can compare like your highway or 4 lane or 8 lane highway that we have. So on this highway, UPF will act like highly intelligent traffic control system. It means what? It ensures that all the car, it means your data packet, are routed correctly to their destination. So whether it's locally state, it means nearby the location, or it's a cross-country road trip, it means data traveling across the internet. So if you have enforced the speed limit and the traffic rule, that you can say that cost policy to make sure emergency vehicle like a V2X, URLCC, they have the high priority data so that they can get to the faster which they required. So if there is needful lawful interception is required, if you help by keeping an eye on the traffic of each and every category. So, and ensure that everything runs smoothly and secure. So that's why EPF is very important, because EPF will provide you anchor point of inter-rat mobility. It's a similar to like SGW that they were doing in LTE. So here, UPF will serve as fixed point in the network during the handover between the different radio access network technology like LT to NR or NR to LT. So that UPF also provide you packet routing and the forwarding. It manages the routing and the forwarding of the user plane function data packet across the network. Then if you have the most important, you can say that implementation of the cost policy and the marking packet using QFI cost flow ID. So if you enforce quality of service, it means it ensures whatever the data flow need to require that we have to meet according to the service quality level. So we have the different 5 QI that we are providing. Then we have here traffic usage reporting. So it provides the report on the data usage for the billing and the network management function. And the last one we have triggering of the data downing buffer data notification. So the EPF notify the AMF when there is a downing data waiting for the device that is in the ideal mode. Then it can trigger the network page when they use and they deliver the data. So these are the functions that we need to provide here. So I hope guys, it is clear up to here, everybody. Okay. Now we have a beautiful architecture that you can see. So this is your NG-RAN architecture that we can say. So here you can see that this is the 5G G node B, this is the 5G G node B. If this 5G G node B want to communicate to this G node B, so they have to use XNAP protocol. If G node B want to speak or communicate, so they have to use XNAP protocol. 4G also available that is connected to the AMF and that is connected to the UPF. So when it's connected to the AMF, they can speak with the NG, and when it's connected to the UPF, NG interface. So these are the protocol guys, NGC and NG interface that they are using. So you can see that the communication between next generation eNode V and next generation eNode V, it will change to the XN protocol when I'm using 5G core network. And communication between G node B to the next generation node B XN protocol. So here G node B provide protocol and the function on the NR user plane and the control plane. So both have NR user plane and the control plane function that they are using. So we will see how they are look like. So this is the overall architecture that we have. Now in this architecture, we can see that how your architecture is splitted actually. If you have the architecture like NG-RAN completely, that is called next generation radio access network. In this next generation radio access network, it could be G node B or E node B, anything. So this NG-RAN, it's a kind of component of the 5G network, include all the radio access network. It means it has some responsibility. So what kind of responsibility? So it manage and coordination of the radio resources and interface with the 5G core network. So that's why if you see they are connected via 5G core network. Now then we have G node B, next generation node B. So this is a kind of a base station that we see in the 5G network. It's a successor of LT network where we say E node B. So G node B is the main point of wireless communication where 5G devices carried out tasks where they can perform the modulation, radio frequency, simulation, OFDM, all those things it will manage here. Now, this G node B we had, it's split in two parts. It means they have more flexible deployment. So first part is it split in G node B CU, that is called G-Node B central unit or centralized unit. So this part basically handle the control plane of the network. It means the main function, or we can say that responsible for this one, is that to manage the session management, mobility management, interfacing with the core network. Okay, so here the control plane, we can say the process that manage the network, that can do like a connection, or set up the connection, or manage the connection, or terminate the connection. So that's why here we can say that RRC. Second, we have here that is called G-Node B DU. This is called G-Node B distributed unit. So this is mainly we use for the control plane and also the user plane. So if it is coming from F1C, it's for the control plane. If it is coming for the F1U, it's a user plane. So this F1 is basically a kind of interface between the G-Node BCU and the G-Node BDU, and is split in two parts. F1C mainly handle for the control plane, F1U mainly handle for the user plane. F1C carry the control information, F1U carry the data information. Basically I show you the different, but all the line it will come like here, actually you can say. So then here you have one more interface that is called ng interface. So ng interface, it's the kind of interface that connect the ng ran to the 5G core network. Now ng interface also two interface, one is called ngc and another one is called NGU. So NGC basically is for the control plane that manage the control signaling and the control information. NGU is basically for the user plane that carry the actual user data plane between the WAN and the core network. So overall, this diagram look like this. So if I split this diagram in the bigger layer, it will come this way. Or not this one, next one actually. So here you can see the concept. If you see here, you have F1C interface, F1U interface, and the E1 interface. So these are the new interface that we have. F1C is interface between G-Node B CUCP to the G-Node B DU. Dedicated control plane communication. It means it only convey the control plane information that is necessary to set up and management of the radio bearer and the radio access network. So here mainly they will manage the SRB 0, SRB 1, SRB 2 like this. F1U basically you can say that G-Node B CUCP to DU. It only used for the data purpose. It means it only facilitate the data transfer between the device equipment and the network core. And if you see G-Node B CUCP to the G-Node B CUP, this is called E1 interface. So this E1 interface exchange the information that allow the coordination of the control and the user plane operation. So that's why they have the separate interface and entity. Now, if you see this diagram, so this architecture is split in two part. Okay, so the first part we can say that is called CUCP. Okay, so CUCP means what? Central Unit Control Plane. Means what? It house the RRC and the PDCP. So radio resource control and the packet data convergence protocol layer. So RRC here responsible for control plane signaling with the 5G device to manage the connection establishment, to manage the configuration, or to manage the release or inactive state, whatever. This PDCP basically handle the task like encryption, sequence number, integrity protection. So in control plane, we cannot perform the header compression actually, because control plane data doesn't have any header. They just have information they transmit directly, bypass. Now, in the second part, if you see here, this is the CUP that is called centralized unit user plane. So in this, we have two protocol. One is called SDAP protocol, that is a new protocol in the 5G Service Data Adaptation Protocol layer, and the second one PDCP User Plane Protocol. So this SDAP protocol mainly responsible for managing the cost flow management, and this PDCP protocol mainly manage here forwarding the user plane data, applying the cost policy, and managing the DRV. So these are the tasks they are doing. And if you see here DU, that is called distributed unit. So in this distributed unit, it consists of three protocols. One is RLC, MAC, and L1. So these contain a lower layer of protocol because these are lower layer, and these two are upper layer. Okay, so they involve the function like segmentation, reassembling, scheduling of the resources, arc process, modulation, OFDM. So these are the things that they will manage here. Now, if you see here, they have interface. So what kind of interface they have? So if you see here, XNC interface and XNU interface. So this connect you another G node B. So XNC and XNU basically connect to the other G node B, where you can manage your control plane network and the user plane network for the communication function like handover. So this kind of function or load balancing. So you are using this protocol. Then you have the protocol here that is called F1C and F1U protocol. So this interface between the CU and the DU, and F1C mainly consists of the control plane and F1U mainly consists of the user plane. Then we have the E1 protocol here connect to the CUCP to the CUP. So this one we are using so that they can coordinate how they can manage the control plane and the user plane function. And to manage this, you have the E1 AP signaling. So this application protocol we used over the E1 interface for signaling between CUCP and the CUP. And we have the two more interface that is called NGC and NGU. So NGC basically we use for the control plane communication with the AMF, and NGU basically we used for the carrying the user plane data to communicating between the EPF. So these are the function that we are using here. Now here we can see these are the protocol we have here. So this is basically the control plane between the NG-RAN and the AMF. If you see, so how the diagram look like? So this is if you see the left side, see, when you want to communicate from one entity to another entity, so we have to use in both, we have to use or we have to communicate in the same language. Like I'm speaking English so that you can understand. Otherwise, if I speak my native language Hindi, you cannot understand. So here, when they want to communicate NG-RAN to AMF, so they have to follow this protocol. So in this protocol, if you see, you have some layers. So start from the L1. This is called L1. This is basically the physical layer to handle the transmission of the ray data over the physical medium. Then we have the L2 protocol. It means it's kind of a data link layer. So it provide node to node data transfer so that they can directly connect it. Then we have IP, that is called Internet Protocol. So this protocol layer basically responsible for addressing and the routing the packet of the data so that they can travel across the network and arrive to the correct destination. Then we have SCTP, we can say Stream Control Transmission Protocol. So this transmission protocol offer basically higher signaling transmission reliability, better real-time performance, and multi-homing capability. This is the reason we are using SCTP, not TCP. Then we have here last one that is called NG app. NG means next generation application protocol. So this next generation application protocol is a layer between 5G radio to the AMF, so that they can handle the signaling required for the control plane function. Okay, so what is the NGC function? So here the function we can see, NG interface management means what? It manages the setup, maintenance, release of the NG interface. EV context management, it means it manages the EV context storage and handling the EV state capability and the security parameters. EV mobility management, so it manages the services related to the mobility like handover, cell selection, roaming, so that it will manage. So these all are the protocol function, guys. This is overview. In detail, you can learn more actually. Then we have the paging. So it handles the process of sending the paging from the network to the device. It means it alert the device about any incoming call or any session, so that it will tell you. Then we have the prioritization management. So it manages the prioritization data which are logically flow of the data between device and the network. So these all are the things. And last one is the warning information transmission that manage everywhere. So this is your 5G control plane protocol interface completely end to end actually that you can see here. I'm not going to explain detail because further I have to explain you again. So just look it here. So you can see that this is your device, G-Node V, AMF, SMF, PCF. So now in the left side, if you see, you have in the device two things. One is called NAS SM. SM is session management. So from the device to the SMF, we have one separate entity that is called NAS session management. Then we have NAS mobility management to communicate to the AMF. So these are the function that we had. Then we have here, these are the protocol. So I will explain you later on this one actually. So just I'll explain you here how they are working. So in the RAN side, they are managing with the L1, MAC, RLC, PDCP, RLC. In the core side, they have the protocol SCTP and they are using STTP2 protocol also to communicating one-to-one in service-based architecture. So that's why they are using here. So HTTP2 protocol, basically kind of modern protocol. It's a kind of internet protocol that also you are using. Like in internet, we are using HTTP2. So right now the 5G core is completely cloud based. So that's why they wanted to use this kind of protocol actually. Okay. Now core AMF, already I explained you this part, so I'm skipping. Okay. So guys, if you see when you are using normal scenario, you have to communicate like this. But when you are using service based architecture, all the communication will be happen by HTTP2 protocol. And this is your user plane diagram. So in user plane diagram, you can see you have the device, you have the G-Node B, you have UPF, you have UPF. You have to. Now, so in the user plane, we can see that we have some layer. Okay. So like application protocol, IP protocol, SDAP. So SDAP is the new protocol in the 5G they added, and this is called Service Data Adaptation Protocol. And this SDAP protocol mainly we use for mapping between the cause flow and the data radio bearer. It also marked the packet with the cause flow ID for the cause enforcement. So we have in detail in the further slide, so I will explain you. Second, PDCP, if you see, header compression, reordering, split bearer, duplication, ciphering, integrity. So PDCP perform the IP header compression so that we can reduce the overhead and improve the transmission efficiency. So that's why we apply the header compression. Somehow we apply to, uh, you can say that we apply this header compression in the form of ROSCS mainly for the VONR. Okay, that we can apply. Now we have here that we can see reordering. So because packet has some sequence number. Each and every packet has some sequence number. So when the packet is sequence number, if you're transmitting the packet sequence number 1, 2, 3, 4, and while transmitting, packet is going 4, 2, 3, 1. So you have to reorder the packet so that the other side, the packet they receive in the sequence format. So that we have to make sure कि in sequence delivery should be number 1 2 3 4, not 4 2 3 1. Otherwise, in number 1, if you are putting like hi, how are you, so it will go like this, you, how, so it's not good actually. So that's why reorting. Duplicate detection mostly for the non-standalone where the packets are duplicate and we need to discard, so that's why we are using. Ciphering integrity, we will explain you later. Ciphering simple means encryption, integrating means it's a kind of OTP that you are providing. Then we have RLC layer, that is called radio link control. So here we have three modes. One is called transparent mode, one is called unacknowledged mode, and third one is called acknowledged mode. It handles the segmentation of the large packet into the smaller one for the transmission and reassemble. Then we have the MAC layer, multiplexing, demultiplexing, scheduling information. So I'm skipping this part because time is less. So because all those things we will see again. Now here you can see this is your XN protocol, guys. If you want to communicate between two G node B, so if you want to transfer the control information, you have to use XNAP protocol over the SCTP, over the IP, over the link layer and the physical layer. I already explained you what is this part. And if you want to communicate to the XNU, then we have GTPU. Anybody, any idea what is GTPU? What is GTPU? So GPT means what? GPRS tunneling protocol. Okay. So this GPRS tunneling protocol that we use basically for data. It means the GTP, let me explain you. So if you see here in this diagram, when you want to communicate for the user plane, you have to use GTPU. And when you want to communicate to the control plane, you have to use SCTP. So GTP we use for carry the user data between the G node B network. Okay. So why? Because it encapsulated the data traffic from the user and transport it over the core network. SCTP is like this. Mainly we use for the control plane, particularly when we have the non-access stratum signaling between the 5G core and the radio access network that we are using. Second thing is that reliability and the congestion. GTPU basically it's built upon where UDP, that is called user datagram protocol, which is connectionless. It means what? It does not provide any built-in reliability or congestion control. That's why this make GTPU more lightweight but less reliable. But the other side, if you see SCTP, it provide you more reliable message-oriented transmission with congestion control and the flow control. So it support here multi-homing, multi-streaming, which enhance reliability and the network efficiency, but it is more complicated also. So when I'm talking about multi-homing and the fault tolerance, GTPU here that you have here does not natively support multi-homing and fault tolerance and the redundancy because of their pattern. But SCTP support multi-homing, allow the connection to span multiple IP address for improved fault tolerance and the resilience. So when I'm talking about GTPU protocol performance and the procedure, okay, so GTP because built on UDP, this concept, GTPU has lower overhead, but SCTP has higher protocol overhead, and that's why we have the different scenario for this one. So when I'm talking in the 5G, we have to think because concept is similar to LT. It's not that much, but the function of the GTPU and the SCTP serve different because they have different role. So we cannot judge also. Okay, guys. So now the first protocol that we have here, that is called SDAP protocol. SDAP. So what is SDAP? SDAP means Service Data Adaptation Protocol. So if you see this diagram carefully, so this diagram, if you see SDAP, where it is located above the PDCP. Okay, it means first SDAP will come, then PDCP will come, then RLC will come, then MAC will come. This SDAP protocol is specially designed to support cost flow in the 5G network, which provide cost handling and mapping between the cost flow and the data radio bearer. So if you see that, this is the cost flow that we have to map to this data radio bearer, DRB. So now here, if you see, we have one PDU session. If you see two PDU session here. So this PDU session basically represent the communication session between the network and the 5G device. And each PDU session can carry multiple cost flow, which are finest granularity of the cost differentiation in the 5G. Now, if you see here, we have here what? We have here SDAP SAP. So what is this SDAP SAP? Basically, SAP means service access point. So this is the point of interaction between the SDAP sublayer and the higher layer. So who is the higher layer? UPF. So it is where your cost flow are received from the higher layer to merge within the SDAP layer. Now it's come to the SDAP entity when it's come here, SDAP entity. So this SDAP entity basically perform the function of SDAP so that the cost flow to the data radio bearer mapping and the marking of the cost flow ID on the backend can happen. So this SDAP entity is kind of a support. Now, if you see here, we have here SDAP PDU and we have here PDCP SDU. So this SDAP PDU means what? It's a protocol data unit of SDAP layer. It means what? It means this one encapsulated the PDCP service data unit and add the necessary header for the SDAP functionalities like QFI, RFI that is required. Okay. So this PDCP is providing. Now, if you see here, we have the PDCP SAP also. It means Packet Data Convergence Protocol Service Access Point. So this interface exists between your PDCP entity and SDAP sublayer. So what is the rule? So here, basically it is a point where your SDAP PDU are passed down to the PDCP layer for further processing. Okay, then we have the PDCP entity. So this PDCP entity perform different kind of function that we will explain in the PDCP protocol. Okay, so here these all are connected to each other. Now, if you see radio bearer here. So what is the radio bearer? Radio bearer means nothing but it's a kind of a connection that we use to transmit the data between device and the G node B. And what it carry? It carry the encapsulated the PDU prepared by PDCP layer. So this one you have to map actually, guys. So all about in the 5G when I'm talking about late term mapping. Okay, what is this actually? SDAP. So think like that because you have to understand what is cost flow first and what is the requirement of cost. So think like that. Your internet is a network, is a kind of highway. Okay, in this highway some can drive with 120 kilometer speed, some can drive with the 100, some can drive with the 50. It means it's like a data where you are playing the video streaming, you are playing the V2X, you are watching the movie, or you are doing the interneting surfing. So that is like a vehicle that you need to pass through the highway. So SDAP is like this. So here, all the vehicle are not same. Some of the vehicle have different priority, and some of the vehicle have the different requirement. So the quality of service flow in the 5G, it's very special lane on this highway dedicated to the different kind of vehicle based on how urgently they need to reach their destination. So this service data adaptation protocol here in the 5G act like a traffic officer. So it manage how we can direct each type of vehicle into correct lane and ensure that everyone get where they have to go on, or they are going on the given time. So in the 5G network, this cost flow terminology that we have, these are identify a stream of traffic that have a specific performance characteristic required for the different type of services. So what kind of characteristic they have? So that's why this characteristic we are checking here: packet loss, bit rate, latency, jitter. Okay, so these all things we are saying, and we based upon that we deliver and we provide the better service quality. So what is the role of this cost flow in the SDAP? So basically, this cost flow role is that you can say that each cost flow is assigned a unique identifier that we are saying cost flow ID. And this cost flow ID we use to ensure that packet associated with flow are given to the appropriate handling by the network. So this cost flow, we have to do the mapping. That's why we are saying cost flow mapping. It means SDAP map cost flow to the data radio bearer. Data radio bearer is a pathway through the air interface that has its own cost attribute. So that's why we need to map, because it's not only just one quality of service. You have multiple quality of service flowing. So the mapping is necessary because multiple cost flow may be transmitted over the single radio bearer. You can map in one DRB multiple cost flow. So that's why each one has their own requirement. And this is the reason we need to do cost flow multiplexing and demultiplexing process also. So this is your diagram. You can see that it's look like. So here SDAP entity that we have seen. So this SDAP entity is nothing but it's a logical block inside the protocol stack, where this is responsible for ensuring that the data packet associated to the correct quality of service or not, and whether they transmitted or received correctly or not. That's the function. Okay. Now here cost flow again it's come. It means cost flow is kind of the data stream packet that have a specific cost requirement. So in 5G, cost flow is stated uniquely to meet the aggregate service level agreement based upon your RF condition, latency, bitrate, reliability. So how they are transmitting? So if you see here, it's a device and NGRAN. So any could be the transmitting entity. So if it is the device, the transmitting SDAP entity is responsible for mapping the cost flow to the DRB. Okay, and DRB is nothing but it's a kind of a logical channel with each specific cost attribute for either the data plane. It's not cannot be the control plane. It's only the data plane. So when they are transmitting, then they have to map SDAP header. So SDAP header, we have to map. So SDAP header means what? SDAP header basically, you can say that it's a kind of cost flow identifier, because this cost flow identifier is basically 8 bits octet. Okay. So we need, this QFI has unique identity inside the PDU session, and this the purpose of this QFI is that to ensure that the data packet which is associated with the correct cost flow, they have to receive correctly in the other side. So that's why in this cost flow ID we are putting some header file, like whether we want what kind of entity in other side. So here we have the one thing, we use cost flow ID, then we use reflective cost flow attribute also here. So reflective cost flow is nothing but in the SDAP layer, it ensures that the reflective cost flow assigned at transmission side are consistently applied at receiving side by applying the same cost flow ID which we assign in the downlink side or transmitting side. So that you have to do. So SDAP header structure is like this. So if you add here and you transmit to the other side, so you have to remove the SDAP header, okay, effectively demultiplex the incoming data into the correct or cost flow as per the correct DRV mapping. Then if the reflective cost flow of the DRV mapping apply here, then nothing but whatever the mapping you do, just mirror it. That's all, nothing. So these are the functions for the cost flow. So in the 5G, this STAP is important because we have the different kind of use cases, EMBB or LCC. So STAP header in the 5G, particularly the QFI that are crucial for the 5G network, provide the different services. So this is the region SDAP is managing. Then we have the PDCP protocol. So PDCP means Packet Data Convergence Protocol. So if you see here, you have two layers. One is for the RRC control side and one is for the user plane. So what is this function actually? So let's see. So transfer of user plane data, if you see the right side. So in the user plane data, if you see PDCP responsible for transmission and reception of user plane data for internet, like whatever internet P2X, voice call, or multimedia, uh, WhatsApp, whatever you are using. PDCP layer here provides some kind of services. So what kind of services they provide here? So the most important in the user plane is that IP header compression. It means PDCP employ the mechanism that is called ROSCH, robust header compression. Why we are using? Because we want to reduce the size of the IP header. We want to optimize the bandwidth usage during the call over the air interface. Second thing is that we also apply here integrity and the ciphering. It's in both integrity and the ciphering. So ciphering is what? Anybody, any idea? So I'll explain you ciphering. So ciphering is a kind of encryption. So PDCP basically encrypt the packet to maintain the security and the integrity of the signaling message. So in both the plane, PDCP apply the ciphering actually. Okay. So when they are applying the ciphering, how they can manage? So basically, when you are applying the ciphering, generally you do the key generation. Key generation means what? We do the encryption key we created during the initially authentication process within the network. So when you are doing the process initially, you have to generate one key actually. Okay. Otherwise, you cannot secure, because this key we have to share securely between the device and the network core. And this the key that we are providing here, that is between the G node V and the 5G. So we have to select some kind of ciphering algorithm. So maybe you know about this. We have so many ciphering algorithm. So here we have the ciphering algorithm like AES, Snow, So network here and the 5G base station and the device will agree upon one ciphering algorithm during the setup of the radio bearer. And during this process, they use this kind of algorithm, AES, Advanced Encryption Standard, or they can use SNO. Okay, depending upon what kind of vendor they are providing actually. Then we do the data encryption. So before user transmit the data over the air interface, PDCP layer basically take the plain text of the PDCP data inside the SDU and encrypt them using the agreed ciphering algorithm and the key. And then this data that you have, that turn the data into ciphertext data. Okay. Then it is unreadable without correct key. So only the third part, the person who is transmitting, the receiver has the key. Only that person can read the key. So this is the reason here we are applying some packaging actually, sequence number, and each PDCP SDU is assigned to the sequence number to prevent replay attack and maintain the data integrity in the order. And this sequence number is used during the ciphering process to avoid the same encryption key stream for the different packet. So that's why they are using actually over this scheme. And encrypted data now called PDCP protocol data unit, and that is sent over the air interface. Okay, so that you are transmitting, guys. Now here you can see integrity protection. So integrity protection means what? It's kind of bank OTP. So PDCP protocol ensure integrity protection for the control plane and user plane by adding one integrity check value to each message. And this integrity we call IMAC. Maybe you heard about this terminology, IMAC. That is one message authentication code, MAC. MAC is equal to, if IMAC, then only integrity check passed. So integrity algorithm, you have the different kind of integrity algorithm in the 5G, like NIA. Maybe you know this terminology. Okay, so this algorithm they are using. So we have one key that is called integrity key, that derive from the initial key agreement protocol when device first authenticate within the network. And this key we use specifically for the integrity protection operation. And when you are doing so, you provide one MAC-I. This is called medium authentication code for using for this algorithm. And this MAC is basically digital signature of sort kind of message that you have. So first you encrypt the file, second you provide the integrity key, okay, and then you transmit that packet to the device via radio interface. Then other side you have to do the integrity verification. So when you receive the packet, the device use the same integrity algorithm and the calculated medium authentication code message. If they calculated the MAC which they received, if they match, you confirm that the message is authenticated and there is no alter during the transmission, then they can do this part. So encryption and integrity is very important in the 5G, and that is handled by PDCP layer. Now here you can see that this is your PDCP function. Okay, so in this PDCP function, we have a different kind of function. So you can see that transfer of data. PDCP is responsible for transmitting of the data. It means transmitting the user plane data. PDCP sequence number, maintenance of the PDCP sequence number. It means PDCP protocol maintain the sequence number for each data packet to make sure the data receive in the other side in the sequence manner, and if the packet has any duplicate, so we can discard those packet. Header compression with the help of ROSS, I already explained you. Ciphering integrity, I explained you. Then timer based SDU discard. So here we implement a timer based discard SDU service. It means if the SDU cannot be delivered with the current some time period, so we have to discard it. This basically you can use for the VOLT VNR services, this one. Then routing for the split bearer. So in ENTC scenario, we can easily manage the routing of the data across the split bearer so that we can manage the load balancing and optimize the resources. Okay, duplication. So whenever you have any duplicate PDCP PDU, so we have to remove one. Okay, so here, now here if you see that in this diagram, the PDCP, where it's located between RLC protocol and SDAP protocol. And here we have PDCP SAP, that is called access point. So it interfaces the point between the PDCP layer and the SDAP layer or IP layer. And if you see that RRC layer, you have downside RLC sublayer. So it handle basically the segmentation and the reassembling of PDCP PDO and error correction through the HARC. Then we have the radio mirror that is managed. So this is the logical channel that carry the data between the network. And then you have two things. One is called CSAP and one is called USAP. So you have two things that you are using here. So CSAP basically the control plane, it will tell you, and USAP basically the user plane. So CSAP used for the communicating between PDCP RLC control plane and USAP communicating between the PDCP RLC user plane data. So that you have to manage. Then we have the RLC protocol. So RLC we know radio link control. So RLC has three entity. If you see here, the transmitting entity for the transmission mode, transmitting and the receiving entity for the unacknowledged mode, and we have acknowledged mode. So the TM, basically this is called TM, this is called UM, and this is called AM. So the TM is transmission mode. This TM offer no error correction or retransmission is used for the broadcast information. So that's why if you see, they are just transmitting. They don't have two-way path like this. They just transmit, no feedback, no hard transmission. If you see here, no. Here also in unacknowledged mode, the same scenario. No. So unacknowledged mode, but basic unacknowledged mode will provide you some other things like segmentation and reassembling and allow for efficient transfer without full error correction and retransmission mechanism, because you cannot apply arc here. Only you can do the segmentation and reassembling. But in the acknowledge mode, it provide full error correction through the retransmission, segmentation, reassembling, and ensure that reliable data. So this is the things they are using. So in the RLC mode, you have three mode. One is called transparent mode. So this transparent mode that we have, this is the simplest form of RLC entity. It means what? It does not add any RLC header to the data. It means no override for the sequence numbering, error correction, flow control. So this RRC, if you see, it is handled by which protocol? BCCH, PCCH, and the CCCH. Broadcast Common Control Channel, Paging Control Channel, and the Common Control Channel. Okay, so this one we use just to transmit some kind of system information, master information, that's all, and the paging information. And this is the reason they don't have any over it, because broadcast to all the users does not change frequently. They only come with a certain time period. Then we have unacknowledged mode. Unacknowledged mode provide the lightweight protocol function because it includes the sequence number for in order delivery and manage the segmentation and reassembly. But this unacknowledged mode does not offer any retransmission in case if any of your packet lost or corrupted. So in the Volt T or the VNR, if your packet is corrupted, they will not retransmit. That's why we are saying always when we are in the good RF condition, VoLTE call is good or VNR call is good. When we are in the bad RF condition, the call has a noise because they cannot retransmit it. You can set. It's not like that you cannot set. You can set, but it's not a good solution. Acknowledge mode is most complex but robust for the RLC entity because it provides full set of service for the error correction for the retransmission, in order delivery, duplicate detection, sequence number checking. So that's why this one we use. So what we can say, guys, here we can say that TM mode not handle error. So TM mode does not handle the error. It assumes that the data which will receive correctly from the higher layer will manage any error, directly transmit. VM mode only detect the error using the sequence number, but it will not correct them. It will leave them to the application or the higher layer. So this is the reason you have MAC layer. In the MAC layer, you are performing HARC. Then we have the AM mode. In AM mode, we have both. We can detect the error and we can correct the error using the combination of the sequence number and the acknowledge message and the retransmission. So these are the functions for the RLC. And the last one, that is called MAC layer. What is MAC layer? So MAC layer is basically the medium access control. Okay, so this MAC layer is medium access control. So this one we use for different purpose. MAC layer is responsible for data transfer between the physical layer and the higher layer in both uplink and downlink. Okay, both the direction they are managing. MAC layer also manage the resource allocation. It means it dynamically allocate the optimized radio resources in frequency, time, and the power across the various users so that we can maximize the efficiency and the throughput. So here we have different functions. So what kind of function we have? So if you see here, data transfer service. So physical layer basically provide the actual transmission and the reception of the signal over the radio interface. And in the MAC layer, when you transmit it to the data to the physical layer in the form of transport block. Okay, so that's why if you see that if you have different entity, they only transmit one entity to the physical layer because they can only transmit the data in the form of transport block. Then we have the signaling of the scheduling request. So here, it when the device has data to send, then immediately it will prompt the MAC layer to schedule the transmission opportunity. So they can do the measurement. So what kind of measurement they can do? So they can report the channel quality indicator, which inform the MAC layer about the radio link quality to optimize the scheduling and the resource allocation according to that. So if you see the MAC function, you can identify they do the mapping job. If you see this multiplexing, they do the mapping job. It means this MAC layer map the logical channel to the this channel, physical channel, and they can map the data in the control plane, user plane, transport plane, whatever the required actually. Demultiplexing and multiplexing of the MAC SDU. So MAC layer basically combine the multiple MAC service data unit into the single transport block because they cannot transmit separate because we wanted to make them more efficient transmitter and separate them at the receiving entity. So their job is this. Then here we do the HARC, that is called error correction through the HARC. So MAC layer also manage the HARC process, which are critical for the fast error correction because we want to improve the link efficiency. Then we have the logical channel prioritization only for the uplink. So in the uplink, MAC layer determine the order of the logical channel based on priority and ensure that higher priority communication like control signal or the data signal, whichever. So which one is the highest priority, we will transmit first. So these are the functions. And if we compare to the LTE, MAC multiplexing reflects the RLC concatenation. So in LTE, if you remember, the responsibility of combining the multiple RLC PDU into the single PDU, that is called concatenation, has been shifted from RLC layer to the MAC layer. So why they did? Because they want to optimize the processing and the transmission on the data radio. So this is the funda. Okay, so thank you so much, guys. I didn't take break, so but I hope you like the session. Have any doubt, anything you can ask. We have a good complete actually protocol training. We wanted to